All right, guys, we're here on section 2.9, inverse functions. And before we get started on this one, I always like to kind of go over these three vocabulary terms over here because they are often confused. And I want to make sure we really understand the differences between these three terms. So in math, opposite means negative. And so, for example, the opposite of 5 would be negative 5. And also, for example, the opposite of negative 5 would be negative 5, which would be, in fact, positive 5. So it does mean just switch the sign. Or if you want to think of it as negative, that is the definition of opposite. And so we don't want to confuse that with reciprocal. So reciprocal means flip the fraction. And so for flip the fraction, for example, you would go from 1 over 2 to 2 over 1. So notice all I did there was flip the fraction. I did not change the sign this time because the definition of reciprocal is just flip the fraction. Now, a lot of people get these two confused because when you combine these two, that's when you're talking about the perpendicular slopes. Perpendicular slopes. So that's kind of just one specific thing in math that you learn where these two are combined, but there's other applications of them individually where you don't use them together. You may just do the opposite or you may just do the reciprocal. But if you do both of them, kind of the only time you do that is for perpendicular slopes. Now, we don't want to confuse either of these with what we're learning today. So what we're going to learn about today is inverse. It does not mean opposite. It does not mean reciprocal. It means switch x and y. So that's our big idea for today, is that inverse means switch x and y. It really has nothing to do with opposite. It has nothing to do with the reciprocal. That is just our process for finding the inverse, is switching the x and the y. All right, next up here, we'll talk about one-to-one functions really quickly, and the horizontal line tests, which are connected. This is a function for which for every y value, there's only one x value. And then we got the horizontal line test here, and so that's a test to see whether a function is one-to-one. If a horizontal line hits the graph more than once, the function is not one-to-one. So this is just a specific type of function. I would say that the vertical line test is still kind of infinitely more important than this. And so we're going to see, for example, here, our first graph, number 1, identify if it's one-to-one. I see if I draw a horizontal line through this, it does hit the graph more than once. So that's a fail of the vertical line test. So I'm going to say no on this one. It's not one-to-one. And if you notice what that graph is, it's a parabola, one of our favorite graphs probably. So like I said, it's okay if a graph is not one-to-one. It's just something we need to consider. So the next up here we have, it looks like a square root graph. It looks like any horizontal line I draw here will not hit the graph more than once. So I'm going to say, yes, this one is one-to-one. All right, next up here, we're going to find some inverses algebraically. This is going to be kind of our big idea. And so we got our steps over here. So step 1, we're going to switch x and y. And that's kind of what I mentioned at the definition at the top. It's our big idea for the day. Next step is going to be to solve for y, which is to isolate y. And then our last step is to call y f inverse of x. And for inverse, we use the, it looks like a -1 power there. I really don't want you to get confused on that one. It is kind of confusing, so I'm going to say it down here. We can make a little note. F inverse of x does not equal 1 over f of x. I know usually the -1 exponent means drop it down the bottom, but for inverse, for functions, it does not. We kind of learned this earlier when we did, for example, sine inverse of x, and that did not equal 1 over sine x. The sine inverse was when we were looking for the angle, whereas this one over here, we really define that as cosecant. So same idea there, that when we use this -1 power with a function, it does not equal this 1 over thing. Both of these then are instead referring to the inverse. So you just got to keep that in mind, that the rules are a little different for these guys. Okay, so, oh, one quick note here as well. The inverse function inherits the range of the original function as its domain and vice versa. We're not going to be worrying about that too much, but just a little FYI there, if you cared. So what we're going to be focusing on here is we're first going to go ahead and do number 1 here. So I will go ahead and switch x and y. So we're going to say x equals 5y minus 2. Next up, we're just going to use all of our algebraic tools here to isolate y. So I'm going to add the 2 over, say x plus 2 equals 5y. We'll divide by 5, and then I have isolated y there. But just the last step here is step 3, which is don't call it y. I'm going to move it out front, and I'm now going to call it f inverse of x equals x plus 2 over 5. So that's going to be my final answer. All right, next up here, I'm going to go ahead and do number 2. You may want to pause it here and go ahead and try number 2 on your own. But I'll go ahead and do it now so you can check your work. So we'll just go ahead and start off first switching x and y. And then we'll go ahead and isolate y. So I'm going to subtract the 7 over, x minus 7 equals 3y. And then divide by 3. We have our y isolated. And we'll call this f inverse of x equals x minus 7 all over 3. We like to call it f inverse of x because it's kind of just referencing the fact that it had it's the inverse of the previous function. Okay, so now we'll go ahead and do number 3. So for this one, we'll go ahead and switch x and y. So x equals the square root of y plus 1. And then we will subtract 1 to the other side, so x minus 1 equals rad y. And then we'll square both sides. And so I would write this as f inverse of x equals parentheses x minus 1 squared. If you wanted to write that twice and FOIL it, you could. So that would be, you could also call that x squared minus 2x plus 1. I think it's fine. It's just x minus 1 in parentheses squared. Remember, you're not allowed to just send that squared in there. That is against the rules for parentheses with adding or subtracting on the inside. All right, next up, number 4. Same idea here. We'll go ahead and switch x and y. So the square root of 2y minus 5 minus 2. And we'll add the 2 over. And then I would square both sides. And so we got 2y minus 5 equals x plus 2 squared. And then I would add the 5 over. I'm just going to go ahead and leave this in the parentheses like that. And then we'll divide by 2. And so that is my final function there. I'll go ahead and just label it as f inverse of x equals out front. And there we go, x plus 2 in parentheses squared plus 5 all over 2. Once again, you could expand that x plus 2 squared, but I don't really think it's necessary. All right, next up we got number 5 here. So for this one, once again, we're going to switch x and y. Oh, I haven't mentioned it here, but when you have f of x, that really means the same thing as y. The cube root of y plus 2. And so now we'll subtract that 5 over, so x minus 5 equals negative cube root of y plus 2. Now, notice that I was really careful because that negative was in front of the cube root, so now I'm going to divide that over. So this will be negative x plus 5 equals the cube root of y plus 2 now. And now I'll take both sides to the third power. And so I get y plus 2 equals negative x plus 5 to the third power. And I'll just subtract the 2 over and write my final answer now. F inverse of x equals parentheses negative x plus 5 to the third minus 2. Remember, once again, we're not allowed to just send that third power in there because of the addition in there. Okay, lastly here, let's go ahead and tackle number 6. So for number 6, once again, just switch x and y. And then you can multiply both sides by y minus 3, because I don't want to isolate something in the denominator. So this will cancel out. There's actually a couple ways to go from here. You could distribute that x in. What a lot of people like to do instead is to just divide both sides by x at this point. So I'm going to go ahead and do that. I'll show you what the answer would have been if you would have distributed in there. It'll be kind of the same either way. So we have y minus 3 equals 2 over x. And then we'll just add the 3 over to the other side. And so one way you can write this is f inverse of x equals 2 over x plus 3. However, if you did distribute it in there, you're going to get the same answer as this, but it will be it'll be this answer if you did a common denominator and added them together. So if I made this 2 over x plus 3x over x, to get a common denominator, it would come out to 2 plus 3x all over x. And so that answer is also correct. Two ways to write it. I would assume that WebAssign would accept both. All right, next up we got number 7 here, and this one's a little tricky because we got kind of two x's here, top and bottom. But what we're going to do is just our same process. So I'm going to change all the x's into y's. And my next step will always be, if I have this where y is in the numerator denominator, I'm going to multiply this over here. Okay, so in this case, I do want to distribute that in there, so it's going to be 5xy minus 4x equals 2y plus 3. Now, in this case, I'm trying to isolate y. I see we have two y's that are actually in unlike terms. Whenever this happens, and we kind of saw this in earlier chapters, you want to move everything with an y, since that's what we're trying to isolate to one side, everything without a y to the other side. So I'm going to add the 4x over here. And I'm going to subtract the 2y over here. And so what that'll look like with these canceling will be 5xy minus 2y on the left, and then 4x plus 3 on the right. And now that I have both of these y's on the same side, what I can do is factor one of them out. And then divide this over here, and I'm done. So my final answer would be f inverse of x equals 4x plus 3 over 5x minus 2. One quick note on that is that another equivalent answer for this, and I'll write this up here, would actually be if all of the signs were switched. So if it was negative 4x minus 3 over negative 5x plus 2, that would be another equivalent answer. If you think about it like you're multiplying the top and the bottom by -1 on a fraction, it's still an equivalent fraction. Where that might come up is if you isolated your y's over on the right side and moved these guys on the left side, you get this answer instead, which is still technically correct. All right, next up here, we want to verify that these two are inverses, and the very popular way to verify this is to do the composite function, and if the composite function comes out to just x, they are inverse. So you can plug either one of these into the other. So I'll just go ahead and do f of g of x. And so for me, that's f of x to the 5th plus 3. And so if I take that, I have the 5th root of x to the 5th plus 3 minus 3. I see that 3's cancel out, and I have the 5th root of x to the 5th, and so that comes out to x. And so that's just my proof, if I get x as the final answer on the composite function, that these are inverses. If it comes out to anything else, if it comes out to x squared, if it comes out to 2x, if it comes out to 0, they are not inverse functions. So same idea here. And so I'll just do f of g of x. So that's f of x plus 3 over 2. So 2 times x plus 3 over 2 minus 3. So since these are multiplying, I can cross cancel. We get x plus 3 minus 3, and so that gives me x as well. All right, next up on the graph, or a table, either way. Well, actually, why don't I go ahead and graph f of x here, and see it's 0, 1, 1, 2, 2, 4, negative 1, 0.5, and then negative 2, 0.25. And so this graph looks like this. I think it's actually clear here that this is y equals 2 to the x power. And so if I'm going to make a table for the inverse here, I would just switch the x and the y. Pretty simple. And so this graph would be looking like this. 2, 1, 4, 2, there and there. And so this graph would be looking like this. And so something you can always know about inverse functions is that they do have a reflection of each other, and they are reflected over this line right here. Right here, all inverse functions reflected over the line y equals x. So it's like a mx plus b, it's 1x plus 0. This actually makes sense, reflected over y equals x, because that would actually switch the x and the y. And so you can see that's what happens here. If you fold it along this green line, these graphs would match up. One more quick note here. What is the inverse of 2 to the x power? Well, this is actually something we're going to talk about a little bit later. But this would be log base 2 of x.